In question number 21, we're asked to convert back and forth between polar and rectangular coordinates. In question 21a, we start with the regular Cartesian or rectangular point x comma y, which is given as 4 comma negative 4. To convert to polar, we need to use the equation r equals the square root of x squared plus y squared. We plug our x and our y in. We should find that r is equal to the square root of 32. This can be reduced. The perfect square 16 goes into the square 32. So you can break it down to 4 squares of 2. In order to find the angle, remember the angle theta should be such that it satisfies the equation, the tangent of theta equals y over x. Therefore, the tangent of theta is going to be negative 4 over 4, which is equal to negative 1. And if you go back to the original ordered pair, remember this was the point 4 comma negative 4. This would be an angle that lies in quadrant 4. The angle in quadrant 4, whose tangent would be equal to negative 1, would be the angle 7 pi over 4. So now that we know r, we know theta, we have our polar point. It's going to be the ordered pair 4 comma 7 pi over 4. In part B of this problem, they give us the polar coordinates, and now we're asked to change it back to rectangular coordinates. To do this, we need to use the equations x equals r cosine theta and y equals r sine theta. We know that x is going to be 8 times the cosine of 11 pi over 6. The cosine of 11 pi over 6 is radical 3 over 2, and therefore this is going to be equal to 4 square roots of 3. The y value should be equal to 8 times the sine of 11 pi over 6, which is going to be 8 times negative 1/2, which is going to be negative 4. Now that we know our x and our y coordinate, we can put it in our point form. It's going to be the ordered pair 4 radical 3 comma negative 4 in rectangular coordinates.